Submarines built from reinforced steel get crushed like soda cans at the bottom of the ocean. But fish, they're just vibing down there. How is that possible? Stick around because what you're about to learn will completely change how you see life on this planet. Imagine being 11 kilometers below the surface. That's deeper than Mount Everest is tall. At that depth, the pressure is 1,000 times what you feel standing on the beach right now. 1,000 atmospheres pressing down on every square inch of your body. A single submarine hull costs millions of dollars to engineer, and even then, only a handful can survive the journey. Most would implode before they even got close. Yet down there, in that crushing darkness, fish are swimming around like it's no big deal. Some are hunting, some are mating, some are just existing in conditions that would obliterate you and me in less than a second. So what did they know that we don't? Here's the thing. Your body is full of air pockets. Your lungs, your sinuses, even tiny air spaces in your ears. Air compresses under pressure. It gets smaller and smaller until those pockets collapse entirely. That's what happens to submarines. They have air inside. Pressure pushes inward, and eventually the structure can't take it anymore. Boom, implosion. But deep sea creatures, they don't have air pockets. None. Zero. Their bodies are made almost entirely of water, and water doesn't compress. It's incompressible. So when pressure pushes on them from the outside, their insides push back with equal force. It's like a tie in a tug of war. Balance, equilibrium, no collapse. But wait, if it were that simple, wouldn't every fish be able to go down there? Why do most fish die when you drag them too deep? Because there's more to the story, way more, and it gets wild. Let's talk about what these creatures actually look like. Ever seen a blobfish? You know, that sad, squishy pink blob that went viral? That's not what it looks like in its natural habitat. At depth, the blobfish looks like a normal fish, but when scientists drag it up to the surface, the pressure drops and its body can't hold its shape anymore. It goes full blob mode. Why? Because its body is gelatinous, soft, flexible. No rigid bones, no hard structures, just jelly-like tissue that can bend and flex under extreme pressure without breaking. It's like the difference between trying to crush a water balloon versus trying to crush a glass bottle. The bottle shatters, the balloon just squishes. Now here's where it gets insane. These fish have a secret weapon, a chemical that sounds like something out of a sci-fi movie. It's called TMAO, trimethylamine N-oxide. Yeah, it's a mouthful, but this molecule is the key to survival. Here's what it does. At extreme pressures, proteins in your cells start to collapse and denature. They lose their shape. When proteins lose their shape, they stop working. Your cells die. You die. But TMAO stabilizes those proteins. It holds them together like microscopic scaffolding. The deeper you go, the more TMAO these creatures produce. Scientists have found that the deepest living species have the highest concentrations of TMAO in their bodies. It's a direct correlation. Deeper equals more TMAO equals survival. But here's the kicker. TMAO is also what makes fish smell like fish. That weird, funky odor when you open a can of tuna, that's TMAO breaking down. So the secret to surviving the deepest, darkest, most hostile environment on Earth? It smells like your least favorite seafood section at the grocery store. And it doesn't stop there. These creatures have evolved flexible cartilage instead of hard bones. Their skeletons bend. They don't snap. Think about it. Hard, rigid bones would crack under that much pressure. But cartilage? It's like rubber. It absorbs force. It adapts. Even their cell membranes are different. Most animals have saturated fats in their cells. Those fats are stiff. They turn solid under pressure, like butter in a fridge. But deep sea creatures? They use unsaturated fats. Those stay fluid, like oil. No matter how much pressure you apply, they keep flowing. They keep working. Let's talk about the Mariana snailfish. This little guy holds the record for the deepest living fish ever recorded, 8,000 meters down. That's almost 8 kilometers of water pressing down on it. And get this, it has gaps in its skull, actual holes. Why? To let pressure equalize. No air pockets to collapse, no rigid structures to shatter, just soft, squishy tissue and open spaces. Scientists also found that this fish has mutated genes that control bone formation. Those genes are broken on purpose. Evolution turned them off because rigid bones would be a death sentence at that depth. Then you've got the anglerfish. You've probably seen pictures. The terrifying face, the glowing lure dangling in front of its mouth. That glow is bioluminescence, chemical light produced by bacteria living inside the fish. And the body? Gelatinous, squishy, built to handle pressure that would turn you into a pancake. These things look like nightmares, but they're perfectly adapted predators. They sit motionless in the dark, waiting for something to swim close to that glowing lure. Then bam, dinner. Giant tube worms are another level of insane. These things live near hydrothermal vents. Those are underwater volcanoes spewing superheated water and toxic chemicals. Not only do they survive crushing pressure, but they're thriving in boiling poison. They don't even have mouths or stomachs. They rely entirely on bacteria living inside them that convert chemicals into energy. Imagine not eating, ever, just having bacteria do all the work for you. That's their life. And here's something even weirder: deep-sea giantism. This is a real phenomenon where creatures grow to absolutely massive sizes in the deep ocean. Giant isopods. These things look like pill bugs, but the size of a football. Japanese spider crabs with legs spanning 4 meters. Why does this happen? Scientists think it's a combination of factors: cold water, high pressure, slow metabolism, longer lifespans, less competition for food. All of it adds up to creatures that just keep growing and growing. Now think about this. We've explored less than 5% of the ocean. 5%. That means 95% of the ocean floor is completely unknown to us. We know more about the surface of Mars than we do about our own deep sea. What else is down there? What other adaptations are we missing? What creatures are thriving in conditions we haven't even discovered yet? Because here's the truth. Life finds a way. It doesn't matter how extreme the environment is. If there's even the tiniest opportunity, evolution will exploit it. These deep-sea creatures aren't just surviving, they're thriving. They've turned one of the most hostile places on Earth into home. They've rewritten the rules of biology, and they're doing it all in complete darkness, under crushing pressure, in freezing cold water, surrounded by predators that look like they crawled out of a horror movie. So the next time you're standing on a beach looking out at the ocean, remember this. Beneath those waves, kilometers below the surface, there's an entire alien world. A world where the laws of physics push life to its absolute limits. A world where creatures have evolved superpowers just to exist, and we're only just beginning to understand it. What's the craziest deep-sea creature you've ever heard of? Drop it in the comments. And if you want to see more mind-blowing ocean mysteries, hit that subscribe button. Trust me, the deep sea has way more secrets to reveal.